Hey everyone, my name is Joseph Jimenez. I am working on Chapter 9, Problem 69, and it reads 500 gram blocks of wood are 2 meters apart on a frictionless table. A 10-gram bullet is fired at 400 meters per second towards the blocks. It passes all the way through the first block and then embeds itself in the second block. The speed of the first block immediately afterward is 6 meters per second. What is the speed of the second block after the bullet stops? So we're going to treat this problem in two different parts. The first part being that we're going to calculate the momentum of the first block, and then we're going to calculate the momentum of the second block. So what's given to us is the mass of the bullet, the velocity of the bullet, the mass of the block, and both blocks are the same mass. So we're going to use M1, M2, but they're the same, so it's 25 kilograms each. Then we have the initial velocity of the first block and the initial velocity of the second block, which are both 0 meters per second because they're both stationary before they get hit. And because they're both 0, I just took them out of this equation. So right now I have the mass of the block times the initial velocity of the block is equal to the mass of the block times the final velocity of the block times the mass of the first block times the final velocity of the first block times the mass of the second block times the velocity of the second block. So right now from there we're gonna solve for that, and so I'm gonna pause it and write some more down, and then from there we're gonna solve for the momentum of that first half of the problem. Alright, so from there I did the algebra so that I could get the final velocity of the block on one side and everything else on the other. And so from here we're going to use all of our knowns, and so we're going to multiply 0.01, which is the mass of the block, times the initial velocity of the bullet, which is 400, minus the initial velocity of the block times the final velocity of the block all over the mass of the block, and that is actually supposed to be 0 right here. And once I solve for that, I get a velocity of 100 meters per second. And so with that, that is going to be the velocity of that first block and the final velocity of the first block. And so now we're going to talk about the second block. I apologize. I put bullet. I said block, but it's actually the bullet. I'm getting confused with all the B's. But once the bullet comes out of the first block, it's still at 100 meters per second. So it went from 400 to 100 meters per second. Okay, so because the initial velocity of the second block is 0, I just took it out of the equation. And this is the equation we derive when we know that momentum of the initial times the momentum of the final is equal to each other. So this is what I put down, and we're treating the bullet and the second block as a separate system. So I'm going to rearrange the equation so that I can get the final velocity of the block on one side and all the other pieces on the other. So I'm going to do the velocity of the bullet, which was 100 meters per second, times the mass of the bullet, which was 0.1 kilograms, and then divide that by both of the masses combined, which was 0.5 for the block and then 0.1 for the bullet. And that's going to give us an answer of the block moving at a velocity of 1.96 meters per second. And once again, it's just recognizing where to use systems on their own versus using it combined with something else, as well as knowing the formulas and recognizing what's given to us at the beginning of the equation, and think about what we need to solve for and just rearrange things algebraically to be able to get that answer. So thanks for bearing with me. I know it's kind of long, so thank you. It's problem 69.